Hello and welcome back to a new video here on the Ludwig Fusel channel. Today we're going to continue on with our INI-Parser in C++. So what we have previously done is we have implemented all the infrastructure that we need. We have implemented an exception class that extends on the runtime error to just alias our INI-PP exceptions. We have implemented a base class for the parser, which contains a state on which state the parser is currently in, contains function to add something from a file, from a string, to reset it, or to parse the actual KV pair, which is a virtual method, as well as the function for processing characters and the internal states and members to keep track what the parser is currently looking at. Now, on top of this parser, we have implemented the sex parser. The sex parser was a simple XML API, which is in general just used for just a callback-based API, which in this case, as you can see, it's called parse KV pair. It's implemented in here, and it's constructed by a callback, and this callback can be called later on, and the callback itself is an STD function. We learned this new STD function thing, which is in general just a very smart function pointer, or you could also call this a delegate, because really you can put in everything in here. You can put a function pointer to a member function, to a public function, to a static function, to whatever you like. It just needs to fulfill that. You could even write a lambda, but that's something we haven't explored yet, I think. Now, in the main, we have used it. We have implemented my fancy settings provider. This is a class that is building on top of that. And the fancy settings provider is providing settings to the O stream. So it's requiring an O stream during construction. It has a kickoff function, which is called when it shall parse it, which has a default parameter of the file to parse, which is the config.ini, where it created a sex parser. And this sex parser was basically created by binding a function to it, which is basically the callback. So the callback was bound by that call here, std bind, which purpose is just to bind like a function pointer to a member function, a instance, in this case is this instance, and a hint on how many arguments needs to be supplied to a callback. So the general idea is on KV pair, this function could be, we could have different ones of them. We could have one with 1 argument, 2 arguments, 3 arguments, 4 arguments, 5 arguments. And to basically tell the std bind what we are doing, we use these 3 placeholders because we have 3 arguments that we want to use. And we use the instance on which this shall be called. And we have bound this member function to the parser, or to the std function that's used for creating the parser, the callback. Where is it? There it is. The callback function there, and after that we called add file on the parser, and calling add file basically means adding a file, parsing a file, and this called the onKVPair function, which just outputted the section, the key, and the value to the O stream, and we executed this on a std string stream. The std string stream is basically how did I do this? Yeah, the string stream is basically a temporary memory buffer, and the temporary memory buffer was provided to the fancy settings provider here, the my fancy settings provider, by calling the constructor with it, and then we called the kickoff function. And basically what this kickoff has done is going in here, binding that to a sex parser, adding a file on there, and then parsing it. And later on, we of course need to kind of like get the data, but we don't need to get the data from the settings provider, because the settings provider was supplied with the string stream and it printed to the string stream. So the data is actually in the string stream, and then I just have written this to the myfile.ini. I don't know why I call this myfile.ini. Myfile.txt would be more what it's doing. So let's do this to a .txt file, and let's run it and see if it still works. Should it still work? Just that you are back on point here, and also I also need to get back on that. Actually, it's more the case why I'm doing this, because I need to get back on track. It's not doing anything, that's correct, because it shouldn't do something, but what we should do, if we click refresh, we should have a myfile.txt, which contains the data from the INI file: owner, name, John Doe, organization, ACM, widgets, Inc., 192.02.62, IP address, 43 as a port, and the file And this is exactly what was written in here, but now printed in a non-INI style, like we have done it in my fancy settings provider. And that's all working and all good. But that's not what we want. What we want to do is we want to have a DOM API. The DOM API is already declared in here. We have the DOM parser. And the issue here is that we do not have any implementation, right? If we have a DOM parser, it shall like output something at some point. And that's what we want to do today. Today we want to write some data structure similar to what we have done in C on the INI-X.h. We have written like structs with a key and value pair, a section with a name and keys, and so on. So what we basically have done is we have implemented multiple structures to contain the data. And that's what we want to do here today as well. So let me quickly delete the fancy settings parser. We don't need that one and we don't need that one. Actually, we do not need anything at all. We're going to start in from an empty implementation and we're going to work ourselves up to what we got. All right, so let's start by the ini.hap and let's start by actually implementing the data structures. Now, what you could do is you could directly write these classes on here or these structs on here, however you want to do this. We're actually going to do this in classes because of operators, and we're going to get to this in a second. Now, what you can also do is you can put this in onto a new namespace. What I like to do is namespace this in here, and I'm just going to call this namespace X. This works like that. You can actually nest namespace together, so you can have one namespace and then you can go deeper. Or what you could also do is you could do something like that, have the namespace X up here, and do something like INI-PP X, and then have all the X stuff in here, and plain INI-PP down there. This is just how you like it, how your taste is. Maybe we should do this like that today. No, I'm actually going to do this differently. I'm going to put this in there because that's how I like it. I like to have my X in here. All right, so what are we going to have? We're going to have a KV pair again. And again, I'm doing this as classes. You're going to see why later. So class KV pair. We're going to have a class section. And we're going to have a class document. Because the document is going to be our INI document. No, it's not sex, it's DOM, because it's a document object model. Yeah, because it's a document composed out of sections composed out of KV pairs. So DOM, document object model. Or modeling, or whatever, but the idea is that I have mistyped this here. So we have a document, a section, the KV pair. Now, a document is going to have multiple named sections. So let me just write this as a comment. Let's maybe do this as private quickly, and see what we got. So private, like that. I haven't written code in quite a while because I have had multiple exams in university and some other stuff like founding the company for the YouTube channel in my mind, so I haven't written much code recently, but that's okay. So we have like the document section and KV pair, and the document is going to have one document is going to have n sections, and the section relation is actually been done with a name. A section, one section is going to have multiple KV pairs, and they are actually going to be addressed by the key. A KV pair is going to have strings, right? We already know strings, std string, key. I'm an idiot. So key, value. So that's what we got. We have a key and we have a value that's stored inside of a KV pair. Did I already introduce you to the dm_syntax? We already used that one. That's good. All right, so that's very straightforward, right? A KV pair, very simple. We can do it like that. Maybe we also want to provide some constructors for the KV pair. Now, I'm just going to be quite simple here. We're going to have a default constructor. We're going to have a constructor that is constructing out of strings. Now, did we talk about string views? Did we do this? Yes, we talked about string views. Interesting why I haven't used string views in here. Yeah, because they are std strings. Yeah, so it's fine. So let's actually use string views. We talked about the concept, so we can use them. Key value, And I'm just going to do this one in line here, because it's very, very simple, the constructor that we want to use. All the other ones are created by default, and I don't know why you are underlined, but it should go away in a second. So yeah, the idea here is to construct this. We can use one for providing key value pairs and a default constructor for a key value pair. Now, I do want to have a few functions here. I want to have a const std string reference name function. Actually, this one should be inline because we're going to have it going to be in one line. It is going to be no except because it's always going to succeed. And it's also going to be const, so const no except, and I'm going to return the key. And yeah, that's the key. But I shouldn't call this then name. I should call this one key because I'm an idiot. So there we go. Now we can get access to the key. And then I also want to have a inline const std string reference value, which is going to be a raw access to the value. I'm just going to return the m value. There we go. Now we have everything that we need. We have some constructors and we have access to them. Now the KV pair is done for now. Very simple. Now the only thing left to do is to write the section in the document. Now, as I told you, the section is going to have multiple KV pairs. And the document is going to have multiple sections. Now you could implement this by a linked list. We have done the linked list, I think. Did we do the linked list? I think, yeah, we have done a linked list here in the cats and dogs. We have implemented the linked list, and what we could try to do is have a linked list of sections, have a linked list of KV pairs, and then search through the linked list and search until we find the correct name. It's a potential that we can do. We could do this. It's possible that we do this like that and implement it like that. However, as I told you, we tend to use the standard library. At least if we're doing normal business software and non-real-time high-performance software, we want to squeeze out the last millisecond. We in general use the standard library, right? It's the way we go, we roll, we use the standard library. Now, the standard library does come with containers, and actually it comes with a container that is completely suited for us. It is the map. The std map is having quite an odd name, the same like the std vector. An std vector is basically a dynamic array. I don't know if we use it, but std vector is a dynamic array, and it's called vector and not array because array is a fixed array and vector is like a bit different concept here. And the same is what we are doing here. What we are now trying to do is we are trying to take a section name or a key name and assign it a value. So we wanna have a key value pair. Even though the KV pair is already the KV pair is already a class, we actually want to have a KV pair that is kind of like containing as a value a KV value pair. And that's something that the std map is doing for us. And there are two kinds of map that you can include. There is a normal map that you can include, and there is a unordered map that you can include. What we want to use is the unordered map, not the normal map. The difference between them is the normal map. It's going to contain all the items in the order you have inserted them. Even though it might accelerate them otherwise, but the general idea of a normal map is if you later on iterate through the map, you're going to get the same order than you have added the elements into the map. If you have an unordered map, the map is unordered. The elements are maybe appended at the front, somewhere in the middle, or at the end. You can't tell where the elements are appended. On a linked list, we always append it last. So when we iterated from first to last, well, we got it first to last, the same order than we have included it. And if we include something like vector of the standard library and use an std vector, we basically get the exact behavior that we had on the linked list, just with a bit of a different syntax. And the unordered map is not like that. The normal map it's like that, it's the map, but if you iterate over it, you're going to get them in the same order than you have added them. If it is an unordered map, you will not get them in the same order, since the order in our case doesn't matter. We just want to have key value pairs. Since the order doesn't matter, it's fine. We do not need a normal std map. We can use an unordered map. So let's use a std unordered map here. So std unordered map, and let's call them mkv pairs. pairs, like that. And now you can see that we are actually not able to create an instance of an unordered map. And if we are hovering over it, it says argument list for class template SCD unordered map is missing. So similar like what we have done on the linked list is that we need templated arguments. On the linked list, we basically use the argument on what we want to put into the linked list. And it's actually the same as well on the standard library. You always tell it what to put into that. For example, the SCD vector that I have now spoiled a few times but not used. Let's use it. The SCD vector, which is basically a linked list but maybe implemented differently. If we do create an SCD vector just out of curiosity, it also requires template parameters, and if I would then say something like SCD, like the KV pair, I could actually now create a vector of key and value pairs, or KV pair pointers. One thing that doesn't work on the standard library is our references inside of there, because references cannot be like this constructed and bad things happen. So if you're storing something, you store pointers or the actual values themselves. So what we can do is a SCD vector of KV pairs, which would now give us a linked list basically, however this is implemented. But what we want to do is we want to have a unordered map, and the unordered map, if we press Ctrl space, we have two parameters that we need to supply. You can see that there is like an hasher, which is equal to k to hash of KTY and whatever. We don't care about all of these that have like already some arguments. We just care about the ones that don't have like an equal sign and a default argument. We just care about the underscore KTY and the underscore TY. So KTY is the key type and TY is the type. So we have a key type and a type, and since we have key and value pairs, we basically need to know what's the key and what's the value. Now the key is going to be strings, right? Because the sections is going to contain keys and they can contain values. So the key is a string. Well, it's the same type than we had in here. We had for the key a string in there, so we should also have a string in here for the map. So that's the key. What's the value? The value is the KV pair. And as you can see, if we do it like that, everything is fine, no more issues. We have a SVT unordered map from string to KV pair called MV KV pairs. And by having a unordered map, we basically allow the access to that unordered map by the array operator. So actually what we can do on an unordered map is, if we would have something, let's maybe make the section now public here so that we can implement some things. So if we would have like a void temp, let's quickly create a void temp so that you can see what I'm doing. And if I would now access the MKV pairs, come on. Why is it so slow currently? Yeah, I'm just mistyping it. And what I can actually do is I can access elements like that. So what I can do is, if I do like KV pairs at my key, I can actually access them. And if I would have IntelliSense, which I don't have for some odd reason, I would actually be able to access like the key function here. The function key or value. Let's maybe access the function value. It's a bit more prominent. You can see that this works because this is actually like an array. The unordered map is kind of like an array, but you can index the array by the keys. In this case, a string. So my key gives you access to a KV pair element, and it's similar to an array, but it's not accessing the data by an index. It is a whole different data structure under the hood, but what's happening here is that it kind of like behaves like an array, but the key to the array is no longer like an index that starts at 0 and goes to n-1. No, it is actually the type that you specify first, which is the std string. Now there's a hell of a lot of stuff going on behind the scenes to make this fast and reliable and prevent collisions and stuff like that, but you're gonna give them unique keys, and you can do this. Now, what you can, of course, also do is you can assign them, right? You can do something like my key equals to KV pair of lel lol. This is something that works as well. We can create a my KV pair and assign it. We should also be able to std move something in here to assign it. Or what you can also do is you can do something like call an emplace function. Emplace actually means insert, and I think you can emplace like that. Let's quickly see if it likes that currently. I don't know why, if it's liking that in the current state of the standard library, but it is like something like key value. Something like that would also work. And actually what that is doing, it is actually inserting something that's called std pair. And a std pair is actually a pair of a key and value set. And in this case, it's a pair of std string and kv pair, which is constructed like here, kv pair, key, value, stuff like that, and probably now have a bracket issue. But that's like also a way to insert data, right? The first one is the most straightforward one. We just assign the value. However, you also have in place functions. These in place functions are useful, especially like that in place with an std move of kv pair. If it's not default constructible, if kv pairs is not default constructible, because as far as I'm concerned, you cannot really directly access them, because this one here is actually giving you a reference to an existing kv pair, which means that the kv pair needs to be default constructible if you assign them. If it is not default constructible, this will not work because it's giving you a reference, even though you are moving. If you're moving, you're just calling move assign. In this case here, we don't have a my key in there. If we don't have a my key in here, it's going to default construct one, return a reference to the default construct one, and then calls the move assign. If you do want to insert something new, you need to... I'm not quite sure if move works down here as well, but it should. You need to do it like that. Either that way with move, or like that, or maybe even no move at all. You should be maybe also possible to just do it like that, because this one is creating a default one. However, this could mean that it tries to copy that one. So std move is definitely something that might be required there. But that's like the idea, right? You can call in place if it's not default constructible, but that's like a whole different story. All right, so that's the general usage idea of a map. So now let's actually implement how we want to do this. So first of all, we do not need to specify anything of the big five, because it's all handled by the standard library, because we're just using unordered map. And the standard library is of course already fulfilling the big five for us. So what we just need to do is we just need to implement the features that we need. And what I actually want to implement is I want to have the array operator on the section, so that we can actually access the key and value pairs. So how I'm going to do this? Well, I'm going to do something. I'm going to write kv pairs reference, because that's the return type that we get, operator array. Now the thing that we had is a const std string reference. It needs to be a const reference of the type of the key, and this is kind of like the key that we are trying to access. And what we do here is we just return kv pairs of key. Did I mistype anything? Yeah, but that's the idea, right? We're just gonna redirect this to that one, so make this one inline, and it's all good. Then we would have also a const version of it, so inline const reference of a const there, and this doesn't work. That's interesting. Why can't we use the array operator of the standard library in a const way? That's really odd. Okay, interesting. Maybe we would need to... If I would be like... What I can do is I might be able to do that, but is this one... No, this is not const. So find is not working in a... No, const iterator. It does. It is const. Interesting. Yeah, I see what the problem is. You need to actually give this a second one. Okay. Now to explain the code that I've just come up with, I need to talk a bit about what find is and how iterators on a map work. Now on a map you have a key and value pair, so if you are iterating over the map, you're not just going to have values, you're also going to have keys. So if you're iterating over a map, if I could do this like here, so auto iterator equals kv pairs begin for the first iterator, and what this iterator now actually is is it is a container. It is actually an iterator to an std pair. If I would dereference it, it's an std pair. However, if I use the pointer operator, which is also like dereferencing the iterator and trying to call something on it, we actually gain access to the std pair. So now we have an std pair of a std string and a kv pair. And the first thing that's in there is always the first thing that you specified on the map. So the first thing of the std pair, which is the string. So iterator first is the key. Iterator second is the value. And this is like the idea of the iterator on a std map. Now, the find function on the map is a function that tries to find you a value based on a key value with an iterator. So if you are doing something like kv pairs find with a string, it's always returning you an iterator. It's always going to work. It's returning you an iterator. If it is the end of the map, or if it cannot find this, it's going to be the end of the map. So it's going to be equal to mkvpairs.end. So if it didn't find it in the map, it's going to be the end iterator. If it found it, it's going to be a valid iterator. And if it is a valid iterator, you can use the pointer operator in second, even though it's not a pointer, it's the class iterator. It's an instance that's locally existing, but it is kind of like a pointer. It behaves like a pointer in this case, and you can then access second to actually get the value. Now, why did that one not work? Why did that syntax not work? Well, because this is the array operator. And if you are actually doing this with the array operator, it is always going to work. If you're doing the array operator and the element is not in existence, it is going to insert that one and give you a reference to the newly created object. So really, we might not even want to have that syntax here at all. We might not want to even use the array in general. We might actually want to duplicate that whole line and use it like that, to always use find, because find is going to try to find it, and if we are using the pointer on an invalid iterator, it is going to throw an exception and everything is going to be bad. But it kind of like behaves like an array operator here in our case, but this is actually what we want. We do not want to have the map creating a new object on the fly with the array operator. So we want to make ourselves a bit more convenient with that. Now, this is definitely no except, because if we would be no except, it means no exceptions, and this can fail if it is an invalid iterator, so if it was not found in the map. So that's the concept here of the map. So very simple. We have the array operator, and the array operator tries to find something in the map based on the key, and this returns us a iterator, and the iterator has a parameter second, and or not the iterator, it returns us an iterator to an std pair, and the std pair has an attribute called second, which is actually the second one in here, which is our value. The first one would be the key, but we don't care about the key. We just care about the values. Now, what I also want to be able to is I want to be able to access all the keys that are in the section. Now, how am I going to do this? Well, I'm going to do this with a vector, and I think I ordered them visually. So let's move them up. Let's do this with a vector so that you learn what a vector is as well. So I want to have a function that gives us all the keys that are in our map. Now, how can we do this? Well, what we are going to do is we're going to create a std vector of our keys, which is an std string. And this might now be the place where we might want to alias our key value. So I'm going to call this one keyset, the function, or maybe just keys to get access to the keys, and it's going to be constant because it's not going to modify this. However, what I'm going to do is I want to say, yeah, let's make this public using std, or using key equals std string, right? This should now alias std string as a key, and we could easily change this one. So this one will then get a constant key in here, and this will be a vector of keys, and this would be a map of key and a key value pair. Makes this a bit more readable and gives it a bit of more syntax on what we are doing. Why is it a string? No, it's actually a key, but the key is a string. Yeah, this might be also bad, but if we are hopping over that, but it should be okay. Maybe these ones should be strings so that you can see it a bit better, but I think it's fine like that. Now, how can we create a key set? Now, I would be really spoiled if I already have a function on the map, but I don't think so. key equal. No, I do not have a function. Like in Python, you can get the keys very easily. But in C++ not. Now in C++ there are multiple ways of doing that. What I'm gonna do is I'm just gonna create a vector. Let's see, let's call them keys here. I'm gonna create a vector. This one is gonna be an empty std vector called keys. And what I'm gonna do now is for auto iterator equals mkv pairs begin. It not equals mkv pairs end. Iterator plus plus, or plus plus it to be a bit more performant. And inside of the for loop, keys, which is a vector. Now the function we can call here is emplace or pushback. Normally what you see if you're using vectors, you're always going to see the pushback function. So we're going to call them pushback, and pushback is going to push something back to the vector. So it's going to append this to the vector. And in this case, we want to have the iterator's first element, and the iterator's first element is going to be the key. Now iterating over a map, an unordered map or a normal map, it doesn't matter. On the normal ordered map, and just an std map, it's going to be in order, and an unordered map is not going to be in order, but the general idea is you're going to get all elements in here as std pairs, and the std pair has a first and a second, and in this case the first here is our key. So what we are just doing is we are copying these over, and then I'm going to return keys. Now I think this might be doable in less lines with like template magic and standard library magic stuff, but I think for now this is sufficient. Right, so now you also see how the vector works. Now how does that now comes in place? Now currently it's not coming in place at all because we are not actually able to append something or to push back something, but I personally like to just call this now append. So what we also need is a void append. And what we're gonna append is a like a const key reference key and a kv pair move semantic pair. Or let's just call this value. And what I want to do in here is I want to say mv key pairs and place key std move value to add this to the set here. Now I am explicitly not using the array operator just to not void construct something. Directly moving it in is always better, it's always more performant, and yeah, it should be good. So now we should have a proper section. Now what I want to do is I want to quickly pause and quickly show you that the sections work before we're going to continue on. So using namespace INI-PP, let's do this like that. Then we're going to have a DOM section, and the section, actually the section does have a name, so I do want to continue on keeping the name of the section in here. We did this with the KB pair as well, so I want to maybe also have this here, std string name, so the name of the section. And I do not want to change volume of the VM, which has no speakers, but that's okay. So now the section itself, did I make the key v pair default constructible? Yeah, so let's make this one default constructible as well. So that's default constructible, and we can do this with a const std string view reference name. And what we do is that the name is equal to the name, and everything is good. We can now create the section. Now let's also add a inline std string reference name function const. No except returns the name there, so that we have access to the name. What? Yeah, it's an inline const std string reference. There we go. And now we should in theory be able to create a section with a name and call this one like dummy. And then I can say section append, and I can append a key for a kv pair or a DOM kv pair key value. No, of course. Let's do this like that, maybe value. And now what I then later should be able to do is I should be able to get all the keys that are in the set. So let's do something like stdc out and do something like keys. or let's just call this kv of, and it's going to be the kv of section name. So it's going to be the name of the section here, std handle. And what I'm then going to do is for, and now I'm going to use range-based for loop. So for auto reference key in my section keys. Section keys is going to give us the vector, and what we can do is we can use this range-based for loop like we've done with our own linked list, and we can iterate over them. We could do this like as a const std string reference here. This is basically what we have in here, but const auto reference should also be fine here in this case, but this doesn't need to be. It actually doesn't need to be anything at all. We can copy this around. Reference is always a bit better because it might not create a copy for the key here for iteration. So let's maybe do a reference there. And then let's do a simple cout and do something like I do want to have the key, and then I want to actually have the value. So section for key. Let's get the value here. And let's do an std handle here. We could also gain the actual name or the key value also from the section here, but I can just do it like that for example. Now what I would expect here is to get like the dummy section and one key value pair if I didn't make a mistake, but it looks good. And yeah, we're gonna get the kv of dummy, the name is key and the value is value, which is exactly what we got, key, value, dummy. And just so that you can see a bit more what's happening there, let's go in with the with the debugger, and let's take a look at the locals. So you can see that we have the section down here. You can see that the section has a name called dummy. Then there we have the kv pairs, which is an unordered map, but it's telling us that the size of the unordered map is 1. I can open this up and you're gonna see it gets like this hash function key equal allocator and raw view, but what we care about is not the raw view because this is like the actual layout of the map. We don't care about the map's layout. Visual Studio is gonna present this as in a nice way. Next to these 3 default parameters, you're gonna have all of your keys, all of your std pairs shown like that. So you're gonna see that you have like the key and the brackets with the string symbol here, so you can see that we are having an entry for key, and in this entry for key you can see that the first parameter is the key, which is like the key value, and the second one is the DOM kv pair. And if I open the DOM kv pair up, this is now actually the class that we implemented. We have an m key of key and an m value of value. So that's how it works. This is how it looks. It's a bit more complicated because we're using standard library stuff and amazing things, but yeah, that's the general idea behind that. So you can also visualize your data and everything is good. All right, so now let's continue on and write our document. Now, the document is not going to require too much explanations here. So the idea here in general is that the document is at a similar level to how the section is, right? The document has a list of sections, and the sections are also named. So the idea is the same. I do want to have this as well, so let's do maybe a public using. Let's call this one. Yeah, key was now, let's say, yeah, let's also call this one key. Let's call this one key here as well, and let's use this here as well inside of this document class. This, of course, works because key was declared in the section. So it's section key, and this key here is document key. So we have a section key and a document key. They are both the same, but they are not conflicting because they have the same name. Now, a document doesn't have a name, right? We could attach a name from the parser, but I don't want to. I don't need a name. I just want to have an unordered map from key to section. Now, yeah, that's what I want. This is now the unordered map from key to section here, and this is gonna be called sections right there, like that. Now, the document is, of course, also gonna have an array operator. Now, the array operator is gonna be a bit different. We wanna get sections, so section reference, or inline section reference, operator, array, and we're gonna have a const key reference name So parameter, this can be no except. And now I want to access the section. Now this one is going to be a bit different here because I actually do want to have two implementations of these. Now I'm going to have two implementations here. One is going to be the const one. That's going to be simple. That's going to be exactly what we got. So a const section reference for a const instance of that class. It's going to be simple, right? This is just very simple. We already had this one. Return msections, find name, give me your second content. Very simple. However, I want to have the array operator if the section is not existent. I actually want to create the section on the fly, right? This is just the difference here so that you can see different implementations. Normally you would have a consistent style. Either you always call an append function or you're just gonna create it on the fly. It has a bit of a purpose that you're gonna see why I'm doing this like that, because sections are something that can coexist. So multiple key value pairs can be in one section, but there can just, or normally should just be one key in a section. So if you are overwriting something, this might be an issue depending on, I don't know what the standard is actually. If the last one is overwriting that, or if it is an error in INI, that's a good question. So I would need to take a look at the specifications of INI if this is actually valid. I think it might be valid, or most parsers might allow you that. We are not going to allow this here, but the most parsers are going to allow you that because they also tend to allow to provide settings. For example, Unreal Engine does use INI files for its settings, for the user settings, for like the game settings. And as far as I'm concerned, what Unreal Engine does virtually is when it starts up, it loads the default settings from the game packs files, from the pack file or from something else. It loads the default values in, and then it loads all the files in the user directories, and it overrides the pre-existing values to kind of like customize the user experience. This is also why like games like, for example, Dead by Daylight that don't support changing your FPS in the game, and it's FPS locked because the servers run at a certain FPS. I don't know if it's still a thing, but previously you could overwrite the FPS of the game by modifying the INI files because they were like an Unreal Engine thing, and the Unreal Engine loaded default values which they set, but they didn't expose it in their settings, but it was still exposed through the default Unreal settings with the INI files. But that's a different story. Now what I want to do here is I want to create a section on the fly. So how I'm going to do this? Well, first of all, I want to have an iterator. The iterator is going to be retrieved by finding it. So I'm trying to find something. I'm trying to find this by the name, and this is going to be assigned to the iterator. Now, if it's already existing, this iterator will be valid. If it's not existing, the iterator will be end. So if iterator is not equal to m sections end, which is the end iterator, if it's not equal to that, we can return it second. Very simple. If it's not equal to end. However, if it is equal to end, we need to insert it. Now, how can we insert the section? Well, what I'm going to do is I'm going to do an auto reference section, and the section is going to be equal to m sections at. And this is now going to be the section at name, and since this is the array operator, it is returning as a reference, and it's creating this on the fly. Now we have it, and what we can do now is we can do something like section or return section. Oh, now we need to create this first. The section equals std move of a new section with a name. That's what we need to do. Now we can return section like that. What you could also do is you could check if the section name is empty and then move a new one in, which would fail as soon as we have empty section names or a default section that is empty. So really what you do is you're going to have this implementation. Now this is kind of like new section, and this is like the existing section that you are doing. And this is like the syntax how you do this. This is creating one on the fly, giving you a reference. You can move a sign and your section name into that, and then you can return the section here as a reference because, well, section is still a reference. This, by the way, auto is... Why is it not... Why is my... I thought this odd Visual Studio shortkey was working, but it does not. Lol. You can see like this is like a section reference, and you then move the new section in with the new name, and you get one here. So actually sections are created on the fly. And now the only thing left to do is to write something similar to what we have got here with the keys to be able to get the sections that are inside a document. Now, I am just going to paste this and modify it because that's what you do, right? You implement stuff once. std vector keys, I'm going to call it sections, and it's going to be called sections begin. Now, this would, I think, also... I'm not quite sure. We could try to do a range-based loop on this. So like auto reference section in my sections. Now what the question is what the section is, because is the section a... Okay, the section is an std pair, so what we can do is keys, pushback, section first, which is looking a bit cleaner. This is something that we might even want to carry up here, and it's not called keys, it's called sections. Sections, sections, sections. There is a rename feature in Visual Studio, but I was too stupid to use it. I tend to think that this is only a Visual Assist thing. So, key first. Let's implement this here as well. Auto reference key in KV pairs. No, this should be rather be called pair. In pairs, like that. And this is looking a bit cleaner, definitely a bit cleaner. And yeah, this is now giving us a document. Now I could try and already test the document, or not test because we're not doing a real test, but try out if the document works here in our main. However, I do not want to do. I do want to write and go straight away with the KV pair parser. So what I want to do here is I want to have a DOM document by default in here, which is my document here. So it's default constructed, everything is good. And the document then shall be handled if a parse KV pair request comes in. Do we have an implementation here for the DOM parser? I don't think so. Why are you not? No, this is the sex parser. Yeah, let's just copy the implementation of the sex parser here because Visual Studio does not like me, and make this one the DOM parser. And remove the implementation to start. So just like that, same signature. Section, key, and value. And the idea that I want to do is I want to go into my document, into my section, and I want to append a new KV pair, a new DOM KV pair of key and value. What? Why did you not work? Yeah. Key. No, actually, this is wrong. This should work like that. I have implemented this one, not correctly. The section should not have a append function that takes a key and a KV pair. No, it should be like that, and instead of getting the key like that, we should actually get the key from the value, like that. This is the proper way of doing it. We do not want to have this one explicitly like that, because we are appending KV pairs and the key is extracted and just internally used. We don't know that there's a vector or std map or whatever is behind that. We don't know that. It's just all magic that goes around behind the scenes. Yeah, and that's the implementation here. So how would we use that one? Well, we need to implement this one. So let's do something like DOM parser, parser. The parser is gonna get a file ./config.ini, and this is everything that we need to do. Now there's just one thing that I missed. I missed that we need to expose this as well. So we need to expose the document. So I do want to have a DOM document, I think document, yeah, of course I have used the German version of that, but we can change that. Document, but it's called document in English. Document. And yeah, I know Visual Studio is sometimes an ugly piece of software when it does not like to parse this correctly. Visual Assist is a bit more, it's a bit better and stuff like that. But yeah, get. Just gonna call this one get. Yeah, inline. DOM document get. Return document. So we can parse. Then we can say DOM document doc equals parser get, and we're going to get a copy of our document. And now we have a DOM document, or yeah, I know using namespace is a bit bad because it's screwing my naming conventions, like an INI-PP DOM parser, and then we have an INI-PP DOM document, and we have the document here. Then we can do something like, what do we have inside the config.ini, which I could query? Let's query the database server, and I could do like, okay, database server dot value. This is something that I might want to output, and I could do something like std cout, and I could see out the database server's value. And if I run this code, I would suspect that we get a IP address on the console. Yeah, and there we got it. This is the IP address, and it's nicely accessible with a DOM API. If I make a breakpoint, we can again take a look at how this looks. We have a document. The document contains out of sections. You can see that the sections that we have is an owner and the database section. The database section in its second one contains KV pairs. The KV pairs contain server with the IP address, port with the port, and file with the quotation marks payroll.dat. And the same if we would take a look at the owner. We also have like second in here in KV pairs, but then just the name and the organization. So yeah, it's exactly what we need. It's exactly that in there what we need. It's a bit nested and deep down the hierarchy chain because we're using standard library and Visual Studio. It's called NutVis as far as I'm concerned. That is like providing these better accesses to the visualizations with like the access and visualization like that. But a general idea that was behind that is that you can access the data as simple as it is done here. Just with the array operator, and this is returning your reference to a section, and this is returning your reference to a key value pair, and you can get the value from there. And I actually want to have the port here, and I want to actually have the port as an integer, and the int is going to be the int is going to be called port, and the port is going to be equal to that, and then I want to std cout the port of the server and do it like that. And we are screwed because the value is a, well, you guessed it, string. Can we convert strings to values, to text? We can. It is no problem converting them by abusing something called a string stream. Now we have used the string stream before. It's in SS stream. It's the string stream, S stream, string stream, haha. And what I want to be able to is I want to be able to convert every, or I want to try to print something in a string view and then take it out of the string view, right? The string view, it behaves like a cout and a cin at the same time, but without printing. So if you are pushing something or shifting something into a string stream, yeah, kind of like printing it to the string stream like you print to the console. If you're printing to that, it's kind of like filling the string stream buffer. And if you're then reading from the string stream, it's taking that buffer to read. So a string stream is kind of like an I/O interface. It's kind of like a temporary buffer where you can push data in, but also push data out. Now, what you can always push in is a string, and it's a string that we always have. We always have strings in our INI, so we're always going to be able to push in strings into this string stream. And the string stream is templated, and it also enables pushing data out. And it enables pushing data out depending on the parameter that is given to it. So basically the type of the shift out operator or read operator, however you want to call this. And this allows us to abuse templates and the string stream to convert every string, every value string into whatever we want. So what we want to write is a template with any type imaginable. And what we want to do is we want to return the type. We're going to call this one t and just call it this one get to get something. So t get. And I might want to have a t reference or like a const t reference default value. Default value is going to be if you're going to have an issue, and I'm going to create this default value by default constructing t like I've done that here. And what I'm going to do now down there is I'm going to write implementation. So what we're going to have is a string stream SS. What? Why are you looking so ugly? std string stream. Ah, yeah, now I'm there. String stream, and the idea is what we can do is we can push in the value, and after that we can take out the value to some arbitrary t temp equals default value. And what we want to do is we want to put in the data in here, and what we want to do is we want to return temp. That's the idea what we do. By default, temp is going to get the default value, then we're going to have string stream ss, we're going to shift the data in here, and then we're going to shift the data out, and we're going to return temp. And this one actually now allows us to do whatever we want. We can now convert this around like we desire. So get integer, and it should work. Of course, without the breakpoint. It doesn't do. Okay, yeah, because that one is not what we should do. But like that, it should work without the S, which I accidentally slapped in while saving. And, well, you get the point. Magic happening. Now, I do want to quickly show you how the magic works behind these, really step by step. So what happens here is that we are creating this temp. The temp is now 0 because it's the default construction of t. The default value is 0, default 0. Now the temp is also 0. Now we have created the string stream. You can see that the string stream is empty. Now, if I continue on, you can see that we pushed in the value. So in the string stream, we have the 143, which is the actual value inside the string stream. And now if we're using the shift out operator, you can see that the temp is now having the 143 value. We're returning temp, which gives us the 143 in the port. It's magic. You just need to know how to use it. These are things like that I learned quite late. This is magic. String stream, if you are allowed to use them on your project, you can use them with templates to convert to any type that you need. You just need to be careful. If you wanna convert this to an std string, let's make this one like an auto. It's now called port, and I don't care if it is a port or not, but I just want to show you an important fallback. We want to have now the owner name. The owner name. And if we do something like that, you're going to see that we're going to fail. We're just going to get John. But we wanted to get John Doe. Why are we just getting John? Well, because the string stream breaks on spaces. The string stream works like an import stream, and an import stream, if you're importing text in the console, it always differentiates between spaces. Spaces are kind of like a separation character. Can we solve that one? Yeah, we can either say our user shouldn't use that, or what we can do is we can provide an implementation of that. What we can actually say, if you are using how was that possible? Now what we can do is, let's see if I'm going to be able to figure out how the syntax was for that, because I haven't used this in a while. What we can do is we can provide a default implementation for that. I'm not quite sure why. Yeah, I think you need to do this like that. If you do it like that, it's fine. Std string like that. You basically tell the compiler that this is... Why is the default argument not allowed? Interesting. We can do it like that. Or not. The default... yeah, okay, I see. The default argument is not allowed because it's already specified up here, but this is allowed. Now, by providing an empty template, you basically say, hey, I do want to provide an implementation for std string, and the get version of std string is just returning the value. Default value is not allowed here. You just need to declare it because it's taking the initial default argument from here, which is the default constructor of t, and in this case it can see, all right, std string, you are providing a special implementation for std string, and by providing the special implementation for std string, you're going to solve the issue, because now the compiler will call your exact implementation for the std string, and you're going to get the John Doe back. Woohoo, there we are. INI-Parser, now written with a DOM API and quite overcomplicated. Thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day. Bye.